My name is Yury Semikhatsky. I'm software engineer at Google St. Petersburg, where I'm working on Google Chrome developer tools. And today I'm here to tell you about some great new features we've been working on over the past year. And before we start, I'd like to ask you some quick question. How many of you here are web developers? Oh, cool, almost all of you. And how many of you know what Firebug is? Again. Okay, and how many of you use it on a daily basis? Yeah, again. How many of you know what Web Inspector is? Yeah, the lower part. Okay. And how many of you know what Google Chrome Developer Tools is? And how many of you use it on a daily basis? Yeah, that's much lower part. I hope that after the presentation you will give another try to developer tools, because they're evolving quite rapidly. And since this is 201 session, I will just skim through the features that have been in the product for quite long, and I will try to focus only on the new stuff. Okay, let's get started. The plan is roughly following. At first, I will briefly describe what Google Chrome Developer Tools is and why we decided to work on this project. And after that, well, to be honest, I don't have too many slides for you. Instead, I will just show you some live demos and to show you how you can use our tool in different development scenarios. And after that, you get a chance to ask some questions. Hopefully we'll have ones. Okay. Most of you know and use what Firebug is, and in short, Google Chrome developer tools to Google Chrome is what Firebug is to Firefox. But it's not a Firebug port in any sense. It's a separate project living in its own repository, and most of its code is shared with other WebKit-based browsers, in particular with Apple Safari. And most of our contributions go directly into WebKit repository instead of the Chromium one. But not all the features will be available in other browsers, because Chrome uses its own unique JavaScript engine, which is V8, and in particular memory profiler, which I'll be talking about today, may not be available in other browsers, at least at this moment. DevTools, unlike Firebug, is not an extension, and it's a part of standard Chromium distribution, and it's been there from the very first release of the product, which means that you don't need to go somewhere and install a separate application or extension or whatever and manage them separately from your Chrome installation. As you probably know, there are several distribution channels for the Google Chrome. Apart from the stable channel, which is default one, there is also beta channel, which is being updated about once a month or so. There is also development channel, which is updated roughly once in a week. And also there is a canary channel, which can be thought of as nightly build of Google Chrome. And the last one is the less stable one, and at the same time it will contain all the latest changes to the product, and in particular to developer tools. And I encourage you to use either the development channel or canary channel if you want to give a try to developer tools product, because it's changing very fast. Okay, then let's go to this next slide. One of the first things you do when you are developing your own web application is mastering HTML and tweaking your CSS styles. And to help you with this task, we have Elements panel. Well, all the developer tools are broken down into several panels. Each of them is focused on a particular aspect of your web application. Let's see what the Elements panel is. Okay, let's go to WebKit. .org and open DevTools using Command-Shift-C shortcut. And you just need to click an element in the page to see it highlighted and revealed in the DOM tree here. You can edit its content on the fly. Oh, sorry. Just need to minify it. Yeah, and see it applied immediately. On the left-hand side, you will find the section called Computed Style, and that is a list of all CSS style properties applicable to the inspected element as the browser perceives them instead of how they were declared in your CSS files. You can expand any of these properties to see which style sheets have contributed to its value. In this case, you may notice that the rule from main CSS can navigate to the source file by just clicking the link. Was overridden by the following rule from green CSS. This section is read-only because it represents you all the parsed and preprocessed values by the rendering engine. You can opt to show the inherited properties, but they are not that useful properties, so they are hidden by default. Below that is the section showing you inline styles declared directly on the element. It's editable. In this case, there are no styles on this element by default, but we can add one and see the effect immediately. Then there's all the matching CSS rules with their selectors and the bodies. They are all modifiable. You can just modify their values. Also, there are styles inherited from the ancestor elements, like in this case, the style inherited from the body. You can navigate to it just by clicking the link to see what's in there. Below that is the metrics section, which represents you the box model of your element, including margins, border sizes, padding, and all the regular stuff. Then there is properties, which displays you the prototype chain of the corresponding DOM element. It will contain, in addition to the DOM properties, it will also contain all the JavaScript properties set by your JavaScript code on the particular DOM wrapper. Okay, DOM breakpoint section, which I'll get back to a minute later. And let's see at the event listeners section. Let's go to google.com. Just select the input box and see which event listeners are applicable to it. There are some of them, and they are grouped by event type. If you expand the particular event type, you will find event listeners in the order they will be invoked when a particular event occurs. In other words, in capturing or bubbling order. Okay, there is one event listener added not directly to this element, but instead to an ancestor node. In this case, it's body. You can navigate to it and inspect it if you need. Okay, that's basically it about the elements panel. Let's go back to the presentation. Until recently, we had two panels dealing with resources and network activity. One of them represented all the new storages added in HTML5, like web SQL, local storage, session storage, and so on. And another one just allowed you to inspect the content of resources loaded by your web page and have a view of the network activities. We examined your feedback and wishes and replaced these two panels quite recently with two other panels. One of them is resources and another called network. Let's take a look at the first of them. The resources panel. Let's go to iGoogle. Oops. It's my fault. we need to sign in. Yeah, and here on the left side, on the left-hand side, you will find the frames section, which is starting with the main frame entry, and you can expand it to see all the resources loaded by this main frame. You can select any particular resource and take a closer look into it. Also, there are iframes available on this page. You can hover over some of them, like in this case over the New York Times gadget, and expand to see all the resources of it. The main resource, images with their properties, and so on. Okay, below that are all the storages available to the web page, including probably one that has been there for the longest period, the cookies. And they are grouped by domain names, and you will find everything you expect to in this under these domains. All the properties are related to the cookies, including whether it's HTTP only cookie, whether it should be transferred over the secure channel only, path components, and all that stuff. And to demonstrate you the databases section, I will navigate to sticky notes example on the WebKit.org site, which is basically an application that allows you to create some nodes, and yeah, they're here. And the interesting part is that it will store all the data in a WebSQL database, which you can observe on the left-hand side here. It's called Node Test. If you expand it, you will find all the tables in that database. You can select it to inspected entries. And also, if you select the database itself, you will get the console where you can execute SQL statements like this. There is also nice, of course, nice completion like this. Yep. And at the bottom of the list, there is application cache entry that will display you all the application cache entries loaded by your web page, and including its type and size. Local storage. This page doesn't use local storage. Let's do this in the following way. Just need to go to console and modify it on the fly. Yeah, you see it appeared under the local storage section. You can add new entries in this grid. Okay. Yeah. Another of the two panels we've added recently is the panel that allows you to analyze the network activity related to your web page, and it's a slightly reworked version of the part of the previous panel we've had for some time. Let's switch back here. Okay. Just collapse console, and let's navigate to gmail.com. I've already signed in. So, and take a look. It started with a series of redirects. You can click on each of them to see parsed request and response headers, to see them, the raw view of them. And there's, of course, status code, request method, and URL. Request and response cookies in this nice grid view are also here once you need them. Okay. For the requests which had a content, you can inspect the content in this panel as well. Can return back to this view, and here, if you hover over the entry, you will find the time it took to perform your request, broken down into smaller components, including proxy lookup time, time spent on setting up the TCP connection on SSL, and how much time we waited for the response. Oops, sorry. Okay. Yep. So I think you'll find it useful. And of course, you can also filter the element by the entries by resource type in the response. Okay. The set of developer tools would be incomplete without a good JavaScript debugger, and we're constantly improving it. Recently, we've added some new ways to set breakpoints in your code, and some other cool feature, which I will demonstrate you. Okay, let's navigate the browser to hovercard example from the closure library. For those of you who are unfamiliar with this library, it's a JavaScript library open sourced by Google, and among other things, it provides you with a set of reusable UI widgets and controls, and those are used in different products like Gmail, Google Sites, and Google Docs, things like that. This particular example shows you how you can use hovercard, which is essentially a rich tooltip which can contain an arbitrary HTML in it, and to see it in action, to see how our debugger works, let's go to the hovercard.js to the line 206. And by the way, if you don't know what are the shortcuts for a particular action, you can just press the question key to see this help screen listing you all the shortcuts grouped by the panels. Okay, and let's set the breakpoint on the line 208 and observe the the execution just paused on this line. On the right hand side, you will find all the regular controls for stepping through your code, for disabling breakpoints, watch expressions section where you can add a particular an arbitrary JavaScript expression which will be reevaluated each time your execution is paused in the context of the top frame of this call stack. Okay, and looking at the call stack, you can notice that each of the functions on it is anonymous function in terms of JavaScript. It doesn't have a name, but we have nicely formatted display names for these functions on the call stack, and that is a feature of V8 engine, which is in parse time just infers these names from the source code. Below that is the section that allows you to inspect all the variables grouped by their scopes, including closures and the global variables, basically all the expected stuff. Okay, let's remove the breakpoint. There's also DOM breakpoints. That's something new. You can notice that here, every time you move your mouse, a new log entry is being added to this event log. If we want to understand which JavaScript does this thing, we just can inspect this DOM element to see it in the elements tree. Go to its parent, which is a div, and to set a breakpoint on any modification made to its ancestors. Okay, let's check it out. Yeah, we just post in the function called addLogRecord. Okay, here's the div being created and then added. Here's the explanation why we post exactly in this method. It says that we post on subtree modification, and we can navigate to the element where the breakpoint was set if you want to modify it. And all the regular inspection utilities will be available as well. Yeah, and okay, let's go back to this overcut.js. Okay, line 206. Quite often you need to make some small changes to your JavaScript code and then redeploy your application, then reload the page in the browser to see the effect of this change. That can be quite tedious, and to help you with such tasks, we've recently added an ability to edit the sources loaded in the browser without need to reload the page. To do this, you can just double-click into any line of the code and modify it, like in this case. Yep. It's applied successfully, and now we can see that the page is broken. Hovercut doesn't appear. Let's set a breakpoint to see what's going on. Yeah, we see that the execution went by the wrong path. Let's try to edit it on the fly and return the previous value. Suppose that we also want to write to the console. Sorry, that is a known issue. Okay, console log, and the value of the anchor element. You see that the call stack has been unwound until the first call frame, whose JavaScript function wasn't modified. We need that to correctly execute the changed JavaScript. You can just continue and see the execution reaches that line that has just been changed. Okay, it works now. Okay. I didn't remove this breakpoint. Okay, and yeah. Now we see that everything is back again. If you look at the console, the elements are being locked here. You can expand to see its properties. Yes. Well, and there are also all the you can hover over an element in your page to inspect, to just inspect values of the particular element. Like in this case, it both includes primitive values like undefined numbers and so on, and also this more complex stuff. Okay. Let's go to the google.com page again. When you're typing some text, there is Google Suggest comes into play, and if you want to understand what's going on when you're pressing key, you can just go to the scripts panel, to the event listener breakpoints section, and choose to pause every time a key down event is being handled in your code. And after that, you will see the corresponding call stack, and well, it's obfuscated and minified, by the way. Not that useful in this case, but you've got the idea. Okay. The page rendering in modern browsers is a quite complex task consisting of many parts, including execution of JavaScript, recalculation of CSS styles, modification of the DOM model, and sometimes it's hard to get a clue on what's going on inside it, and where the time is spent whether it's JavaScript, which is sluggish, or whether it's CSS style, which is being recalculated for the longest period, to help you understand what's going on inside the browser. We have a panel called Timeline, which allows you to record all the events, high-level events, happening in the browser when it's rendering some page. Let's go to another example from the closure library, which is Zippy, and it's basically a collapsible node. You can see it. Let's start recording the events and see them. Okay, and just stop the recording. And here you will find that the click event led to a series of events. You can expand it to see that it was followed by a series of timer install, timer fire, and timer remove events. You can navigate to the code which caused that event. You can do. We will also see the duration of this particular event. And there's also a call stack, and it's available not only for function calls, but also for events such as styles recalculation and things like that. It may be quite useful because some of your JavaScript code may lead to CSS style modifications that are quite heavy in terms of recalculation. Okay, let's go to again to iGoogle and start recording before going there. Yeah, and see what's happening when we are loading this page. It consists of lots of iframes, and you can see that there is a series of load events. Each of them is, by the way, has quite short duration, and we can expand each of them. This one had load handler. You can navigate to the source, as I said, and paint events are also listed here. You can filter out by event types, just exclude loading events and events like paint and so on. You will see garbage collection events here as well. So this tool can be quite useful when you're trying to understand where the time is being spent when your page is being rendered. And speaking of performance, we have a few more tools to help you identify bottlenecks in your application. The first of them is CPU profiler. Let's go to this example using a canvas to render 3D model of a molecule and try to profile it. To start profiling, just need to click the button, and after that, it won't try to instrument your code. Instead, it will leave it untouched and will stop execution of JavaScript each 10 milliseconds to capture the stack trace. And when you stop the profiling, pressing the button, it will aggregate the data and present you in this hierarchical view. It's a heavy view, which means that the function where most of the time was spent will be on the top. Here is line 3D function. You can navigate to it to see its code. Also, the native functions, like in this case, stroke style setter, will be in the profile. You probably cannot optimize them, but you could optimize the number of calls to this function, like here. We also have a tool for profiling your memory. If you are trying to fight a memory leak, which can be quite difficult, let's navigate back. Okay. You you can just press this eye icon to grab the current heap snapshot and see all the objects in the JavaScript heap grouped by their constructor names. Like here, you will find the native objects like code objects here with the memory they occupy in the JavaScript heap, and you can expand them to see which objects prevent them from being garbage collected, which objects are referencing them. Like in this case, HTML div elements are referenced by some root variables, some objects of this type and of this one. Let's perform some actions to modify it and grab the second snapshot. Okay, here you see it compared to the snapshot 1, and this column shows you the difference in the number of objects in the first heap snapshot and the second one. That is the way you can track which objects are actually consuming your memory. And if you are trying to find memory leaks, you can find again all the retainers of this object test, the objects which prevent them from being garbage collected. You can just see them in this profile. And for tuning the performance of your application, we have one more tool, which is ODS panel, and it's basically a set of predefined rules which you can exercise against your web page to find out whether you did such thing as removed all the unused CSS rules from your CSS files, and did you combine all the resources loaded from the same domain, like JavaScript files can be combined into one big file. Let's just run it over against the hover cut and see that it suggests us to combine all the JavaScript files into one to save on parse time and some network traffic. And here also suggests to use gzip to save some network bits. Also we can leverage browser caching by extending the expiration period and all the things like that. And of course there is a console which provides you the Firebug console API, including methods like inspect. You can just navigate to it, just print its value or print it as a JavaScript object. Oh, it may be quite powerful. And there is a link to the homepage of the Chrome DevTools, where you can find some video tutorials on the features we are adding. And also there, I encourage you to file bugs and feature requests if you find that something is missing or just is broken. Just go and file bugs. We're trying to address feedback of our users quite quickly. The links to the bug analyzer, both WebKit and Chromium, can be found on that page, as well as the contacts of our team members. And thank you very much. That's all. Okay, questions? Yep.
Where can I find all these functions to write to the console, such as, I don't know, there or console?
You mean the documentation of all this function, or?
Is there?
No, it's you can just type in Google Firebug console API and you'll find it. Yeah, it's absolutely the same. I mean, the API is absolutely the same. Any other questions? Yep.
Yeah, are you going to support plugins?
We are working on the extensibility of Google Chrome developer tools, and there were many requests for that, and in particular to extend the audits panel to add your own rules specific to your framework. It's not released yet, but some pieces are already in the WebKit repository, and you can probably play with them, but we don't have a specific date yet. So, yep. You mean the Safari Web Inspector and Chrome Developer Tools? Yes, they're basically the core of these two tools is the same. It lives in the WebKit repository. Both Safari and Chrome has parts that diverge, and in particular they use different JavaScript engines, and that means that some bits of functionality will be different. So the basic functionality is the same, but there are some difference. Any more questions? If no, then thank you again. Yep. If you have questions, you can just approach me after the presentation. I'll be glad to answer. Thank you.